Assalamualaikum and good day, student. We will continue to lecture 15, still in chapter 4 under the kinetics of a rigid body. So what we will study here now is pertaining to the it's only limited to the planar system, and then we will look into the two-dimensional problem only. Two-dimensional problem only will be considered. And then as you know, a rigid body is one that not deform at under certain load. And then what we will have here now is this, to study the relationship between external forces, moment, linear and angular acceleration of the body. This is some sort like a revision from our previous understanding in terms of translation. So this is a external forces pointing at the center of mass, and then due to the external forces, this is the motion path. So all particles point in the body move in parallel straight line. This is again the rotation, rigid body plane motion in terms of rotation. If let's say there is external forces over there, and then this is the fixed axis. So what happened to the rigid body? We'll have the curvilinear motion. So we will have the curvilinear motion, and then also the angular motion. So this is a combination of translation and rotation, which we know as general plane motion. Right? Okay, in translation, let's see what we have here is we have several forces, F1, F2, F3 acting at the rigid body. So due to the several forces over here, and then the motion of the rigid body acting at this direction, so this is the motion path. So we call it as a free body diagram over here because it's showing the forces. And then to express in a kinetic diagram, so the free body diagram over here is actually equal to the expression of MA over here within the vector of within the direction of the movement of the rigid body. And then this is the curvilinear translation. Same thing, you have the F1, F2 and F3. So this is the expression of a free body diagram, and then it's equal to the kinetic diagram, where we should consider because since this is the curvilinear, so we should consider the tangential and normal axis. So this is tangential, and then this is normal axis, where we should look into the tangential and normal action occur. So according to the second Newton's law, so what you have here is the total forces acting on the both situation over here is equal to MA. And then another one, we can relate the total moment occurred at point G. Let's say we are putting point G over here. Total moment occurred at point G is equal to 0. In the fixed axis rotation over here, you need to consider the tangential action and normal action, and then let's say this is all the forces pointing to the rigid body, so happen to have the tangential forces and normal forces, and then let's say there is a initial moment inertia, and then there is an acceleration, angular acceleration occur. So what we the equation of motion could be the total forces is actually equal to ma. That is number one. And then number two is the total moment, the sum of total moment at this point G is equal to I G alpha. Then the sum of total, the sum of moment at point O, this is offset to the point G, is actually moment inertia at point O times alpha. Just now is because it's sum of moment at point G is equal to moment inertia at point G times alpha. So it's depending on where you locate the point of moment, either point G or point O. In general plane motion, still there is a few external forces acting to the rigid body, and then due to the combination of rectilinear and translation, so it will have the angular acceleration over there, and then this is the motion path A. So the expression in free body diagram, if we express in kinetic diagram, we need to consider the MA to the direction of the movement, direction of motion, and then the moment due to the rotation of the rigid body itself. This is the one. We still can get the sum of moment either at point G or at point P. So if we want to switch the sum of moment, rather than we taking at point G, we can put it at point P by considering this equation. Okay, first the equation of motion for general plane of motion is F total external forces is equal to ma, and then this one need to obey the sum of moment pointing pointing at point G is equal to the moment of inertia at point G times alpha, and then you can switch the sum of moment to point P must be equal to moment of inertia at point G times alpha plus the MAD. D is the distance of parallel, 90 degree to the offset from the previous move. Okay, let's see the example 1 over here. So the car is having a mass of 2 megagram, and then this is the center of the masses over here. So the statement over here saying that the friction only occur at the back wheel, so front wheel is freely rotate. So neglect the mass of the wheel. The coefficient given, the coefficient of kinetic friction between the wheel and the road is mu k 0.25. So mu k 0.25 only happen at the rear wheel. This is the only parameter given, weight of the car, and then coefficient of friction. Meanwhile, if you see over here, this is the distance between front tire and center of gravity to the rear tire, and then the distance between center of gravity to the to the ground. So from this parameter you need to find the acceleration of the car, determine the car acceleration. Right. Okay, so the statement say that only at the rear wheel it happens to have the frictional force, where frictional force is actually Fr equal to mu kn. So mu k is 0.25, n is normal force at point B. At the front wheel, so 0, because just now it said that it's freely rotate, and then the car is assumed to move to the left. So a few external forces we can consider, which is one, the weight of the car itself, normal force acting at the tire A, and then normal force acting at tire B. And then since given the coefficient of kinetic friction at rear wheel is 0.25, so there is one frictional force occur over here. So that is for external forces. By solution 1, taking sum of moment at point G, taking sum of moment at center of gravity over here. So the first equation of motion that we can use is F equal to ma, pointing at G position, the center of gravity for the x direction. This is at x direction. Total external forces at x direction is equal to m a g, center of gravity at x direction. So this is 0.25 nb, which is this one, is equal to the mass of the car times the acceleration of according to the x-axis. So this is equation number 1. Equation number 2 is we look at the y-axis. Since there is no motion happen pointing at y-axis, so the equation of NA plus NB minus the weight of the car is equal to 0, because there is no motion happen at point at y-axis. So this is equation number 2. And then taking the sum of moment at point G, taking the sum of moment at point G at center of gravity over here. So you look the first one, I'll change the negative NA times 1.25, negative NA, so this is NA times 1.25, because we are taking moment at center of gravity, so meaning that this is in this direction, counterclockwise, so negative. Number 2 is NB times, okay, this is the one, 0.25 NB times 0.3. So pointing at G over here, so this is the radius from center of gravity to the arrow over here, and then plus NB times 0.5. So this is force, external force of MB times the distance of 0.75. So this is positive since acting actually, since NB times radius is acting on the anti-clockwise. So this is equation number 3. So solving those equation, it will reveal the AG and A and NB. Okay, this is the solution if we take sum of moment at point G. Okay, now what happens if we take the sum of moment at point A? So this is solution number 2, a bit easier. Rather than we take the sum of moment at point G, now we are offset the sum of moment at point A. So the equation of motion number 1, what we can have here is the total of external forces acting at x-axis is equal to MAGX, where this is 0.25 MB, 0.25 MB is equal to, okay, this is 2000 actually, 2000 the mass of the car times AG. So this is the first equation. When you switch the sum of moment at point A, this is the one. Then to suit the equation of sum of moment at point A is equal to MAG D, the distance offset. So the first one is NB2, NB, this is NB. So this is the new point A, and then this is the distance, 2 meter. So meaning that this is the direction. And number 2 is minus mg1 times 1.25. This is mg pointing downward. Okay. This is the new point of a moment. So this is the distance, meaning that this is the moment is equal to others forces NA, because it's already pointing at point A, and then FB pointing at A, so we are not considering the both NA and FB forces. Then equal to MAG, M is 200, 2000, AG, and then D, offset, offset from G to A, how much? 0.3 meter. So this is one equation, this is two equation. Equation 1 and equation 2. Solving the equation, we will reveal NB equal to 12.7 kilometer and A is 1.59 meter per second squared. Alright, thank you very much.